All right, welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 2, part 2. Doesn't have to be part 2, but it is, of our broadcast and recording. Where we last left off, before the power went out, we were talking about this. And what I was basically saying was like, hey, take a look at this. This is a warning, and it's not an error, right? The error is if it would be something like this, you can see that that would be like this little, red line, this squiggly line. Or if you had something even like this, that would be worse. Or even like this, that would be very bad as well. Anything like this is an error. And it even tells you there's 3 places for the error, here, here, and here. And if I try to compile this without it being complete, then it would look like this. You get this compile error, right? A build error. And then if I said something like, would you like to continue and run the last successful build? If I press yes, it's going to build anyway, but it's actually not building anything, okay? What this is doing is if you accept that, if you just keep the errors and just press play and then say, yeah, keep going with the last successful build, what this is actually doing is it's running your executable that you built last time. So if you go to your operating system, take a look at this, it's going actually into here, into bin, into debug, and it's running this executable right here, which is already built. So of course it's going to run because it just built it before, but now you have errors and your new thing isn't building, right? So why am I showing you this? If you ever see this error like this, don't press this button because you'll be like, wait, it's working. It's not. You're just running the last thing you built. That's what this is saying. Read it, what this is saying, because I know I got some people asking me. And also the error list is important. At the bottom, it tells you what's happening. Look, new line is constant. Syntax error. It's telling you there's a syntax error. Expected bracket. Syntax error, semicolon, expected, something. It's telling you something is going wrong. And it's telling you approximately, and I'm telling you this is approximately where the error is. That's what it's telling you, okay? There's actually one line of errors, which is this one. But it's saying maybe 16 or 17. It doesn't know. That's what it's saying here. Look, 16 and 17, right? And why this is the case is because it's kind of combining these 2 lines together into one line because there's no semicolon up here. It can't separate these 2 things. It's looking like it's one big statement. Remember, you can put like as many spaces as you want between semicolons. So, right? Doesn't know what to do. So that's why when we get errors, please read what this says, and this can be an indicator of where the problem is approximately. Okay. We can do better than this. We can do this. So this is what we said was, first we declare a username, and then we use readline, which returns a string, and we're going to assign whatever we type in there to username. Okay, now we want to print it out. We want to print this out. So let's do a print out. So we'll say console.writeline, and we'll say we want to print out something like hello, and then username, right? Plus username. That's what we want, okay? And write line should actually be spelled right properly, Tom. Not like this. I'm still upset about the power outage. It's a gut punch, I'm telling you. All right. Does that make sense? And so if I press play here, try this out with me. If I press play here, what you're going to get is this. And you see the cursor is just sitting there blinking, right? It's waiting for your input. If I press enter and don't enter anything, it's just going to say hello, comma, nothing. Like this, right? Because I didn't enter anything. Right? It's null. It's not, I didn't enter anything else. Let's try it again, all right? I print it in there, and if I press, Tom, that's good. I'll say hello, Tom. If I press, here's another thing I can do. If I put anything else in there, right? Yeah, and that, and let's put some other things in there, right? And press enter. It's going to give me this. It'll echo back to me whatever I've entered, right? So, first lesson for you as developers. Day 2, when we're together, first lesson. Anything you get from the user could be a crock of crap. Yeah. And that's the biggest problem. When we look at from a developer perspective, we always say things like this. I'm a programmer, man, things would be so much better if we didn't have those users. Right? The users, they mess everything up, man. The programmers, we know what we want, right? But those damn users, man, they enter whatever they want. They break our code, right? And then, of course, the reality is, the ironic part is we can't be programmers without users. I mean, who are we making this stuff for, right? So we need users, and what we need to do is help the user do error correction. Right? So what we're saying here is, hey, I only want alphanumeric characters. You prompt them and say, like, give me your name, and here's an example, kind of thing. Give me a date. I'm not going to accept any other characters. You can reduce, when we do input, we can do something called validation. We can validate that that input is correct, right? And then this way, you're not going to get crap. Garbage in, garbage out. If you allow the user to enter garbage, you're going to get garbage in, okay? That's the problem. So that's why you see a lot of systems, user interfaces, that are very restrictive. Like you must use a plus up and down button to enter numbers. They won't allow you to enter numbers by yourself. Why? Because people can enter whatever they want. Numbers, characters, letters, emojis, whatever you want now, right? And so it messes this stuff up, right? Especially if you're expecting an integer. Okay, one other thing that's in the PowerPoint is, what if now, I don't just want to enter username, but I also want to enter other data. Okay, so let's do this again. So console write. All right, and I want to do something like this where I say, enter your age. Okay, enter your age. Okay, so there's the console write, enter your age. And now I want another variable. What variable should I use? Well, my age is a whole number, or I could use age as a partial number, like a rational number in math. But that's hard to calculate for some people, right? Like, for example, am I, 30.1 years old? Am I 20.2? Like, how do I do that? So usually we just put the whole number, 20, 30, 40, whatever it's going to be, right? Or 18, 17 for some of you. So we want to make it an integer. So we can say int age. Int is another type of another data type, integer, right? And there's a bunch of different integers we're going to talk about today, all right? But integer is one of those that we can learn. Again, this is also called, it's a primitive type. So, so declare integer type, right? For age variable. That's what we're doing, okay? If I can actually spell declare properly. I told you, man, the power outage was, maybe it was a head punch. I don't know. All right, so I'm declaring an integer type for age. Integer, if you look over, is a 32-bit signed integer. If you hover over the type, it tells you what it is, right? And a 32-bit signed integer, man, that can hold in like a huge number, a massive number, way bigger than my age. My age is going to be like 2 digits, maybe. For some people, I even have 1 digit if you're young, right? And this can hold like crazy amount of digits we're going to show you. So then the question for you is, should we use an integer for age? And for simplicity, the answer is yes, you should. But if you're going to save memory, no, you shouldn't. And we'll talk about how to do that later. All right, so that's the first thing. So now I want to get input. So now, let's see, can I do this? Age is equal to console read line. I want to read line now. Can I do this? Oh, rad line. That's right. Can I do this? It's giving me an error, like Spock says. An error. Let's see what this error is. Back down there, it tells me, it says cannot implicitly convert type string to int. Why is it telling me this? Well, because if I hover over read line, it tells me it's returning a string, but I'm expecting an integer. I cannot convert a string to an integer automatically, implicitly. I've got to explicitly convert a string to an integer, right? And so this is lesson number 2 for today. Number 1, users enter garbage. Number 2, right? Everything you get from a user interface, it doesn't matter, from now and for the rest of your life, is going to be string data. That's what you're getting. It doesn't matter if you're using, if you and I build a mobile device, a mobile app, if you and I build a game, you're getting string data, and you need to know how to convert it from a string to some kind of number, right? So let's think about this. Now there is a convert, if I type there's a convert class, all right? So I can convert, and you can say, you know, again, if I want to convert to int, I want to convert to int32, and you can see that I can kind of wrap my console read line into that kind of conversion, right? To int32. There we go. And convert is the class that we're going to use, and we're going to wrap our console read line inside of my toInt32. Now, if you look at this and you're like, wait, I don't get it. All right? I'm doing this in one line. How else can I do this to make it more clear for you? Okay? Let's do it in another step. This is the fast way of doing it. This is the, you know, a more of an advanced, quick way of thinking about it. Okay? Let's do it the slow way. Okay? I'm going to make another variable, and I'm going to call this age text. So we're going to say string is age text. And I'm going to say age text is equal to console read line. I'm going to do that. Okay? And then I'm going to take the age text here, and I'm going to convert it into a string, from a string to an integer. Okay? That's what's really it's doing. Remember what's happening. Console read line is evaluating into a string. I want to use that word again, evaluating. It turns into string, transforms, transmogrifies, you know, from a human into a werewolf. Okay? It translates into a string. Okay, that's what happens. And then I want you to replace this with whatever you've typed. Whatever I type, it's a string now. And then I store it here temporarily. This is like a temporary variable, a text variable. And then I take that temporary variable, if I put it here, it evaluates into text. And then it evaluates into text, and this toInt32, what does it do? If you hover over, it says converts the specified string representation of a number to an equivalent 32-bit signed integer. How did I know toInt32? Because if I hover over int, it is a 32-bit signed integer. And that's what this does. By the way, convert to whatever, right? There's a bunch of converts, to string, to this, to that, to whatever, right? It's specific to whatever variable you want, or whatever data type you want to convert the input into. We pass in input into this part, this is the method, and it converts it into a number that we can use and spits it out over here. Okay? That's how it works. All right? So I've done it in 3 lines, but I simply could have done it the other way. I'm just going to comment this out so you can see what this is really about. And instead of using an extra variable, I can simply just put in, actually I'll comment this out as well. Hold on a second. And then I'll just copy this again so you see what this is like. This is like me doing this. Okay? Instead of me doing multiple steps, I can just do this, and it's the same thing. Do you see that? If you don't see it, it's okay. But basically what it is it's like doing these 2 steps in one step. Because console read line, I don't really need to store it in a variable, because I'm just going to consume it anyway and convert it into an integer, right? Why would I do a middle step converting it into another type of variable and then back into an integer? It doesn't make any sense. I'm using extra memory for no reason. This is a little bit more simple. Questions around this? Conversion. Conversion, okay? And we need to do this a lot with when we enter stuff in. So let's try this out. I've entered a number, age, and now I want to print out that number. All right, I want to print out that number. I want to say something like console.writeLine. And I want to say something like, you know, username, here's something, is, and then we'll say age, and then years old. Oh yeah, this is really complex stuff. It's crazy complex. It's so complex, you know, my hair is curling from it. All right? Are you with me? So I think you can know what to expect here, right? I'm injecting the username. It's converting into a string, right? I'm adding in is with a space, right, at both ends, because I need a space at both sides, right? And then I'm adding in age, which is a number, which is now converting back into a string again. That's what I'm doing here. I've converted it into a number, and here I'm converting it back to a string, right? And then I'm outputting it with the rest of it. Years old, probably like maybe period would be good. There we go. Full sentence. Let's try this out. All right, so let's try this like little program out, right? So, blah, blah, blah. Please enter your name. So there's Tom. Okay, hello, Tom. Enter your age, 20, right? And then enter, and then Tom is 20 years old, right? So this is awesome, but let's try it again, and let's make it mess up. Watch this, guys. Okay, Tom, yes, nicely, nicely. Age is A, right? And press enter, and it's going to go bam. It's going to cough a lung out, right? Because it's trying to convert alphanumeric character into an integer, and it's like, wait, what do you want? This is no good. This is garbage, right? Yes?
The number, when I typed down 20 for enter my age, it didn't show the number between is and errors.
Okay. Maybe you did something different.
When I typed mine, it was below where it says enter your age. It's below the line.
Maybe you're using right line instead of right?
I put age.
Now I know what's wrong.
I put right line.
Yeah.
Username.
Yeah. So yeah, so this is the way we know. Now there's another way of doing this stuff. This is pretty ugly. Okay, this is pretty ugly. There's another nicer way to inject variables in a string. Okay, we've got an error. There's an error we got, and the reason was it wasn't my error. I coded everything properly. I'm a perfect developer. Hello, right? But it was that damn user. He put an A, right? And that damn user who put in the A, it was his fault, right? No, it's my fault for coding it. I coded it. I made it that way. I gave the ability for the user to put that in. It's my fault, right? Because I'm the one that's coding it. The computer will only do what you tell it to do and no more. It cannot anticipate your needs. It will never do that this way anyway. Maybe in the future it might if it's a robot. I don't know. And that's scary. But anyways, we're talking about something else, right? But this, in case, when we're programming, it will not anticipate what you want to do, and it will error out for now, okay? So there's another way of doing this. Instead of writing it like this is one way of doing it. Let's just rewrite this line. I'm just going to comment it out so you can see that this is the old way of doing it. And then here's the new way of doing it. Console.writeLine. And then if you put in a dollar sign and then quotation marks, right? Now this is different. Now this is another little thing to do, right? Where I can use curly braces for my username. You can actually write it like this, curly brace. And inside the curly brace, you can put username, right, is curly braces, age, years old, like this. Okay, that's also the exact same. Now you must, if you're going to do this, you must use a dollar sign at the beginning because the dollar sign is going to tell the compiler that I'm going to start interpolating. That's what I'm doing. Interpolation is what we're doing here. Before, when I was doing this, I was doing something called concatenation. So this is an example of, you okay? Went down the wrong place? Right? And this is not an example of concatenation. This is an example of interpolation. That's what the formal term is. Interpolation. Okay? Concatenation was when we take these things and add them together with a plus sign. Interpolation is where we inject inside different places whatever we want. Okay? Yes. Even more? Okay. How's that? Is that better?
Yes.
All right, no problem. Mm-hmm.
So does it actually matter which versions that we use to get this?
Doesn't really matter, but I mean, I think the second one is the preference,
It
right?
looks more organized
It's more organized. You don't have to use pluses because look at the difficulty. When we use pluses, we add, it's actually longer, right? I added more syntax. I'm adding pluses. I need to open and close quotation marks. I only need to open and close quotation marks once here, all right? So it's actually a better, more efficient way of doing it, and I want you to do it like this from now on, okay? This is okay, but this is much better, okay? So this $ says, if I hover over, it says, basically what it is it's a raw string. That's what it is, or it's the ability for me to interpolate. If I take the $ away, it doesn't know what I want. It's like, it's just going to print out that stuff. Like it'll do this, watch. If I print this out, it's going to go, watch, Tom, and then, I don't know, 20, and then it's going to say user is age years old, right? Doesn't know what I want, right? If I take the $ away, but if I put the $ back, take a look at that $, then if I try it again, right? And if I do the same thing, if I go Tom and then 20, it's going to say Tom is 20 years old, right? Which is what we expect. So it does that. Is that a hand?
Yeah, I don't know why it was error, but I can't. I've done all that.
Can I get someone to help him out, please? Questions around this? What's happening here? So it's kind of the same thing. I'm going to go over it one more time. Username is evaluated. It's changed into a string, okay? And it's injected in this spot. And then age is evaluated, turned into a string, and injected into this spot. That's what it does. Just like it was here, but it's much nicer in terms of syntax. The way it looks is much nicer, better. It's more succinct, and then we know what's happening. Also, here and here, if I type it in, it starts doing you know, kind of completion. If I type in the name, watch. If I type curly braces in here, and if I start typing, look what it comes up with. It actually suggests username, right? Just a couple of letters. It's suggesting what I should put in there. This is IntelliSense, right? So Visual Studio has something called IntelliSense. Microsoft coined that word a long time ago, and it kind of suggests, you know, how to complete stuff. It's actually code completion. So I want to do that. If you double click on that, it'll actually insert it, right? As opposed to me typing the whole thing. Where this is really great is if I have a really long username or I just can't remember and I start typing a few letters and it comes up. That's what it does. It's almost like a lookup, right? Okay. But we ran into some trouble with this one, right? We ran into some trouble because when I try and convert into age, I can get in trouble because the user can enter whatever they want. Okay? That's what happens. And we're not going to take care of this today because we're a little bit ahead of ourselves when it comes to taking care of this. Next week, we'll try. Okay, we'll try and take care of this problem, and I'll show you ways of making this different. All right, so now that we have this, we have our basic input and output. I can get input from the console, and I can get output. I put output back out to the console. This sequence, this part right here, enter your name like this, and where I have a write and a read line together is called prompting the user. This is actually a thing. So I prompt the user for information. Okay? It's called a prompt because I'm getting input from the console and I'm saving it somewhere else. Okay? That's what I'm doing here. Prompting the user for data. Hey, Tom, give me your name. Hey, Tom, give me your age. Hey, Tom, give me this. You know, give me that. Are you all set up now? No.
You want me to help you?
Helping is a good thing. Helping is learning. Go. Let's see if you can figure it out. And if you can't, then I'll have to come over. You don't want the heavy to come over. You got like, you know, a worker here that can do it. Yes.
So when we start, like, I guess, slashing some comments out just for
Yeah.
leaving information,
Yeah.
it gets to be a lot. Is there a better way to organize it so you can kind of follow better, like color code them or something?
Nope.
No, that's just how
That's just the way it is. Yep.
I'm just loving that right.
You still have it done? It's not right. Someone help him out. One of you guys help him out. So, questions around this so far. Here's something that I've done with you guys. I've added in basic variables, and some of these variables that I've added in so far, this integer, we have a name for it. It's called a primitive data type. Primitive. Stone Age man, the primitives, all right? Okay, Neanderthals, whatever you want to call them, right? That's what the integer is. It's a primitive. String is not a primitive. String is a complex data type. String is a class of things that I can do, right? I have a lot of things I can do with string. Integer, not a lot I can do. It's a primitive data type. And no, you can see that as a struct. So notice that it says integer is a read-only struct. That's what it is. Where if I hover over string, it's a class. String is a complex data type. It's huge, right? String is like I'm using a sledgehammer to get input. That's what I'm doing here, okay? There are other more primitive types than string that allow us to get input from the, like as text. And that is the char or car. Let me show you that one, all right? So here's some other data types, okay? Some other data types. Again, this is only for demo purposes. So you don't have to do this, but it's good for learning, right? So a char data type, right, holds a single character. Okay, so it can say char or car, and if I say something like, I will call this letter, right? Right, that's what it does. And if I hover over car or char, people pronounce it different ways. I like saying car because it's like coming from character, right? So that's just me. I don't like char. It's not like I'm charring anything, like I'm barbecuing, right? So it's car for me, thank you very much, right? And notice when I hover over, it says it's a struct. It's a primitive data type. When you see struct, when you hover over a data type, struct, this word here, it means primitive data type in your mind. Primitive data type, right? And that's what it is. It can hold one character. And the way you initialize it, you can't initialize it like this, okay? If I put this, that is incorrect. Why? Why is this incorrect? Right? It's holding a character, but why is it incorrect? Take a guess. I want you to take a guess why it's incorrect. Go tell me why. Just guess. The quotation marks is why it's incorrect. The quotation marks, because quotation marks mean string literal. This is not a string. This is a car, which means I have to change the quotation marks to single quotes like this instead of double quotes like this. And then it becomes okay. Single quotes are used for single characters. All right? Double quotes are used for strings of characters, okay? And this is syntax. Going back to syntax. This is a car. Very simple data type, okay? One letter it holds. Why would I want to hold one letter in memory as opposed to a string of letters? Well, there's a lot of reasons for that. Yes, you had a question.
It's just also
Yeah.
$sign, that's just the standard for string, right?
Dollar sign means that this I'm going to interpolate. If I take the dollar sign away, it becomes just a literal, right? The dollar sign activates functionality that allows me to inject variables like I've done here with curly braces. That's what it does, okay? All right, so now that we have this, we have car, that's definitely a thing. Sometimes I want to save things in one character, okay? And you're gonna see in future lessons that we can actually make an array of characters. An array is a series or a sequence of data of the same type. That's immutable. You cannot change whatever you put inside that place, right? It's an array of variables, multiple variables, right? For now, we only have single variables. That's what we're having. This is one of them, a car or a char. Here's another one, another data type, okay? We're going to use a float, right? And a float, right, holds a rational number, right? That's what it does. And what it looks like is this, float, and I can say something like, credits, let's suppose in a sci-fi game, right? And I can assign something like 35. Now, if I just did 35, actually this is incorrect. Why is this incorrect? Well, this is an integer. That's the first thing. 35.0. Now we're talking about a float, but it's giving me an error. An error. I'm getting an error, but even though it is exactly what I said, it's a rational number, it's a fraction, right, that I'm putting in here, I'm getting an error. Why? Well, let's hover over and find out. If I hover over, it says, this is a decimal or a double precision floating point number literal. A double, actually. And I'm trying to convert it to a float. And it says there, literal of type double cannot be implicitly converted to a type float. Use an F. Remember I used the F last week? Use an F suffix to create a literal of this type. That means it's listening for an F. That's what it wants. F for float. And I can also make it the same thing. I can say double and call this money, right? And I can do the same thing and it's okay. Those are two types of floating points. So this is floating point types. Floating point types. Okay? And they hold rational numbers. Do you fix them?
Yeah, he tried an extra bracket to find my son.
That's awesome. That's great learning for you. And it's good learning for him. Fantastic. This is what we want in a class that's in person. So why then do I need this F? F means I'm going to make it float. Float is a single precision decimal. Okay, single precision, which means the precision, the number of decimal points I can have after the number of significant digits I can have after the decimal is limited compared to double. Now these numbers are huge, what double can hold. Float holds half of that. Float is a more common and less costly variable. By the way, notice that both float and double are both structs, which means they are what kind of data types?
Variables?
Primitives. They're primitive data types. There's primitive data types and complex data types. These ones are all primitives, yes.
So a float can only have one decimal point?
No, but it has a lot. Like, it's just how much you can represent. We're going to talk about that in a second. It's in the PowerPoint slide deck, right? But it's just, float can represent less than double can. Computers have a funny way of representing data, right? Remember that a number can be very large. If I want to hold something like the number pi, which is a massive number, who knows pi up to 10 digits off the top of their head? Come on, guys. Someone's got to know pi off to 10 digits. You guys are computer people now, and you're also game developers. Pi is going to be something we use all the time with game dev, right? Oh, yeah. Yeah. 3.14159, you know, that's at least, you should know at least that. 26, there you go. Yeah, we got more digits here. Okay. But what if you can't remember pi and you want to do some mathematical computations or whatever? You could use the math class. So there is something called the math class, okay? And there's also the math F class. Okay, those are the two things. I can do something like math.pi, right, which represents this number. Take a look at it. It just tells you 3.141592653589791, right? It's a double. It's a double. And if I want to say that I want to store it somewhere, I can say something like double pi is equal to math.pi, and that's okay, right? Notice that math.pi, math is a class, so I'm accessing pi, which is a constant. I can't change that. Here's a great example of a constant, too, where I don't want pi to change. Pi is a universal number, right, that we use all the time. And we use it for things like the circumference of a circle or the area of a circle or all kinds of stuff, as well as other things that we do here in game dev, right? So here's pi, and I don't want you to remember it. We can just get it from the math class, math.pi, and we can store it here as a double. But what if I went and put this as a float? It's going to say, bam, sorry, math.pi is too big to store inside this floating point number, right? So in this case, we can use mathf. Mathf.pi, right? It actually uses a different representation, a smaller version of the pi number. Look, take a look at that. How it changed from 3.14159.274 and a bunch of extra digits to only this many, and this is good enough to store inside a floating point number. So this is a lesson for you. Floats can store less precise digits than doubles. Doubles store a lot of digits, right? Compared to floats.
So F abbreviates it? Like
F basically says, I want the math class, but provides constants and static methods for trigonometric, logarithmics, and other common mathematical functions, but only floating point level. Not too many more, not bigger than floats. That's what it returns. Whereas if I use the other one, if I said, double, and let's call this pi, just to make it different. These are both different things. And if I said math.pi, right? Notice that this one is a lot bigger than this one. In fact, double the size, double the precision. Look, you see that? Double the precision, right? So double stands for a double precise digit. That's what it is, compared to a single precise digit. There's other ones too. All right, but these are the two most common ones you're going to be dealing with in game dev. All right, make sense? What about naming conventions? Naming conventions are a thing too, right? Like naming conventions are, I've made some really weird names here. Letter, credits, money, pi, and these kind of are very similar and very ugly. You could do something like this. I could say, my int is number 1, and that's going to be equal to 0, and my int is number 2, that's going to be equal to 0, and this one, and I can add all these ones, right? Guys, number 1, 2, 3, 4 makes no sense. They're generic names that have no meaning for us other than that they're a number. Please be more descriptive, right? For example, if I want to say something like, character age in my game, right? And I want to say that the character age is 20, right? That is a descriptive variable, right? And I've written it in a certain way. This is called camel case, right? The camel case, because I have two words, character, and I have age that describes my variable, right? This is valid. And so is this, character age. This is upper camel case. Why is this called camel case, like this? Because you can see the hump, right, when I go to the second word. I'm not joking. That's where it came from. Camel case, because I got the hump right here, right? Upper camel case is where I have two humps, right? Also called Pascal case. These are just names. But one thing that you want to know is that all variables are case sensitive. For example, I can have this variable, right? And this variable, and they're all valid and different. Character age, did I make that? What did I do here? Oh, I already defined it somewhere else, right? Oh, there, yeah. Oh, character age, character age. I meant to do this. All these are valid.
I think you actually copy at the like one capital C and then maybe.
There you go.
Yeah.
All those are valid. I'll be okay. And notice what it did. It said like, hey, these are all the same. If anything is the same, if you're trying to redeclare the same variable twice, like you just saw here, right? It's going to give you an error. It's not going to like that. You can only have one variable of that type. You cannot double declare a variable. Once you've declared it the first time, when you say this, int, and this, once you do this sequence, it's done for the lifetime of the variable. Okay? You never have to redeclare that again. Okay? So these are three different variables. They're not the same variable because they're slightly different. C#, C++, JavaScript, Java, Kotlin, Swift, and any other language that I know, right? Everything is case sensitive. Oh, sorry, one more language that's not is Visual Basic. It doesn't care. But here we have everything is case sensitive. Because it's case sensitive, you have to be very careful not to try and do this. This is an error, right? If we did this. And this is not a syntax error. This is a logic error. This is your thinking error. Hey, wait, I'm going to declare my variable 3 times different ways, right? Don't do that. That's bad, okay? So this is definitely a way of converting. The best way to do it is maintain a constant style, all right? So for example, if you're going to do upper camel case, that's what this is. By the way, you asked about comments. You can also do this, right? Inline comments, upper camel case, right? This is okay too. And this is camel case. This is also called Pascal case, right? And this is just bad, right? Because it's like, it's bad because you can't differentiate between one and the other. Oh, there's one more, but this is okay too. This is just lowercase, right? And you can also do this one, character age. That's also very common, right? Where you separate words with underscore, right? The underscore character, which is this one, right? That's also valid. You cannot declare a variable with a number first. You can't put like this. This is invalid. It doesn't know what you want here, all right? It doesn't know what that, you can't do that. Or any other symbol, all right? You can't put like $, right? Okay, this is not jQuery, like, you know, going back to JavaScript and stuff like that, okay? You can't do that. But you can include other symbols like that inside. Special symbols like $, no, but exclamation marks, or let's say other things like this, like dollar, you see any kind of symbol like that, hashtags, doesn't compute, right? Question mark, all those things don't compute, right? So you gotta be careful what you kind of enter in there. Caret doesn't compute, right? But other numbers, like if you said character age 1, that's okay, right? It's dumb. I don't know what character age 1 means, but at least character age is okay. So which one do I prefer? You're going to see me doing things like this and like this, depending on what I'm doing, okay? There's one other thing that we're going to do in the future when I see you again, probably next year, which is you might see something that looks like this. This is also valid, and there's a reason for this. This means member variable that is private, right? The underscore, whenever you see an underscore in any programming language, on average, means private variable. Now, you don't know anything about public, private, and protected right now, but in next semester, you'll learn all about this with Wallace, okay? So that's what this is. So that's what this means. M underscore is a member variable that's part of a class. Underscore means it's private, okay? It's a very quick way of looking at things. Other things that you might see. Some people, when they code, they put the data type in the variable name, okay? So they do something like this. They do something like int, and then character age, integer, like that. They do that. That's also valid, right? So why do they do this? Because if you look at a variable somewhere else down in the code, right? It could be anywhere in your code. You declared it way up here at the top, and then you're using it way down here at the bottom. It's 1,000 lines later, you use that variable name. Maybe you don't know what type it is, and that's what they've done in the past. They use this, where you can say character age integer. You know it's an integer. And what this saves is trying to assign it to a float or whatever. Now, this is the old way of doing it before we have IntelliSense, right? Where you couldn't hover over like this, and it didn't tell you anything. Here, if I hover over any variable in Visual Studio, it's going to tell you the type right there. Look, it says int character age integer, local variable. It tells you that, right? Guys, use the tool. Visual Studio is going to be your friend. Now, there is a camp, a group of people that are like, you teach students with Visual Studio? That's dumb, right? Let's use Notepad, right? I don't want you to give any help to students at all, right? They should just remember everything, right? And to me, you know, that kind of person, I'm like, yeah, whatever, man, right? I'm not going to teach students like that. What I'm going to do, hamstring you so you can't walk, right? So then you can't do this kind of stuff, make a lot of errors. How can you compile that, right? And, or let's do it by hand. I'm going to give you paper and you're going to write it out with your hand, right? I refuse. Sorry. We're using tools. We're tools users, all right? We're not Neanderthals. Questions around this. So all I'm showing you is there's many ways to declare a variable. What I don't want to see ever in your code, I'm just telling you this right away, I don't want to see this. Why? Why? What are you saving? What are you saving here? A? I don't know what that is. Do you know what that is? It means nothing, right? There is no quota for how long your variable name has to be. You can make it a massive, look, I just made this one like pretty long, right? You can make it like this. This is better, right? Age is okay, right? I know we've done it up here. That's why it's giving me an error, right? But this is okay. Age is okay. But A, unless you're talking about, you know, a triangle, right? A, B, C, and A stands for, right, one of the edges of the triangle, the answer is no. Same thing with X, all right? X means nothing unless it means the x-axis. Then it's okay. X, if it's the x-axis, or Y or Z, if we're referring to those things, good. But do not use things like I, right, as an example, or some weird variable with one character, because it can be at least one character, variable names, right? Or a lot of characters. There's no quota. Make it human readable. I don't want to do this with my comments. I don't want to say something like, this means index, okay? Why would I do that? The variable should comment itself. If I want to make an index, call it index, right? Like this, index. Okay, then you don't need this part. Make it human readable. I want your, and I know this is funny, people say this a lot, your code should document itself, right? But in some ways it does. You have unlimited ways of writing this thing and make it so that it's reasonable for you, okay? I'm getting all of these warnings here, and you must be wondering why I'm getting all these numbers or all these things. Well, if I hover over, it says unnecessary assignment of value to index. The variable index is assigned, but is never used. So what it's trying to do is save you memory. It's saying, hey, you haven't even done anything with these things. Why do you want them? Why do you need these variables if you're not going to use them? That's what this is saying, okay? But notice how I didn't get that with age, because we used age here, right? And so I'm not getting that warning like I'm getting these warnings here. Questions around variable names and naming. Also the math class that I use. Math, by the way, has lots of little great things. Like, for example, if I go math dot, you can see that if you scroll down, there's a bunch of other stuff it does. All the trig functions like sine, cosine, tangent, and arctangent, I'm sure. Here's atan and atan2. All of them, if you want to do any kind of math, like you guys are doing math with Wallace, this can do all that, right? One more thing about math. Who remembers what bedmass is? Thank God. You guys are learning that with Wallace. It's really an important concept because bedmass, or order of operations, or operator precedence, different ways of saying the same thing, right, is what we have to think about. Brackets, exponents, division, multiplication, addition, and subtraction is the order that the computer calculates things to. So please keep that in mind, right? It also has some great stuff. Like, for example, math has power, right? So if I go like pi to the 2, right, it's going to do something like this, where I want to raise pi to the power of 2. That's what this power is. And math also has square root, if I want to get the square root of pi. By the way, as game devs, we want to avoid square root as much as possible with calculations, which is going to be difficult. And here's a reason why we'd want to use square root in the first place, okay? Triangles for you are going to be your friend, or they could be your enemy for life. It's up to you. You need to know triangles, guys, okay, in math. Here's why. I want to find the location. I want to find the distance from this point in space to you. I've got a 3-dimensional location in space, a vector, and I want to draw it to you. I can put us on the same plane, right? So now I just want to make a triangle. I make a, whatchamacallit, a right angle triangle to you, let's say to your head, right, from here. All right, here's the right angle triangle, if you can imagine this as an example. And there's a point here that's going to go to your head, and I want to find the distance. How do I do that? C squared is equal to a squared plus b squared, where c is the square root of a squared plus b squared. I'm using the square root. I want to find the distance to you. I use that for line of sight when I'm firing at somebody. I use it for all kinds of stuff. The distance between me and you, distance calculations all the time. I use it for collision detection. I use it for a bunch of stuff, right? I use it for lighting calculations, right? Square root I could use. But imagine square root is a computationally expensive operation, and if I want to do that every frame, and we're talking frames now, let's say, for example, I want 90 frames per second or something, I'm doing that square root calculation like this, it's going to really bog down my system if I have more than one thing I'm doing. Example would be if I'm ray casting shadows. I'm casting shadows, and there's shadows everywhere. I'm casting rays, same idea, right? And I'm casting rays everywhere, and I'm using square root to do that, and I'm drawing a shadow from the rays, and I'm doing that at 60 frames per second or 90 frames per second, and not just for one object, but for every object in the room. It's crazy, right? We don't do this. So we avoid doing square root of pi, right, as much as possible. Okay, so square root, we can use it, but we want to limit it. If it's only one time per frame, okay. But once we go into thousands of times per frame, it's a bad operation. Also, power is a function, and so is square root, right? What's an easier way to do pi to the 2? Math, guys, math. So let's make a double. We'll call this 2 pi, right? And we'll say that we're going to say math.pi multiplied by math.pi is 2 pi, right? Guys, right? Or pi to the 2. Actually, it should be called pi squared. Right? There we go. 2 pi is 2 times pi. Okay? So this is much easier to do than this, because here I'm putting it through a function, and here I'm just multiplying pi twice. It's just two constants multiplying against each other. Faster, right, than using a function like pow. The worst thing you can do is do something like this, right, where I say something like, I don't know, I have, let's say, we'll use float this time. Float A. And by the way, you can do this too. Float A, B, and C. You can do that all in one line, right? And let's suppose we can also, make it so that we can assign them all in one line. We can say A is equal to B is equal to C, which is equal to 3. Okay, we can do that too. And by the way, if you ever see this, if a programmer does this crap, run away. All right? Remember I talked about this earlier today. Just because you can do something doesn't mean you should do something. Just because the operating system will allow it doesn't mean it's good. This is crap, right? Who can use this? So now let's suppose I want to do the square root. I want to find the distance, as an example, and I want to say c squared. C is like where I want to find it. I want to say c squared is equal to the, or c is equal to the square root of a squared plus b squared. So let's say I do that. I want to say so c is equal to the math. Here we go. Math f. I have to use math f. Math f dot square root, right, of a squared plus b squared. Math dot pow of a to the 2 plus math dot pow with b to the 2. I can do this, right? But it's giving me an error, right? And I probably have to use math f because we're storing it as a floating point number. Like this. This is what I'd want to do. Man, this is crazy wasteful, right? How could I write this different? Well, I could save myself some trouble, and so this is definitely one way. I'm going to comment this out, right? We're talking about mathematical operations here for a second, or arithmetic, if you will. we could always write it like this. We could say that a times a, right? Right? And then plus b times b. You could do that too. Same thing, isn't it? Is this the same? Right? If you really want to be specific, you can use brackets around the a and brackets around the b, right? But at the end of the day, this is the same as this. And this is less computationally expensive than this, because here you're using two functions that have to, you're calling two functions. It has to go do its work, come back, evaluate, then go to the next one, go do its work, come back, and do it again. It's very, very slow. This is terrible. Don't do it this way. Do it this way. If you're going to do square root at all, yes.
You would consider that unoptimized, basically?
This is terrible.
Yeah.
Terrible, right? Don't do it. Can you do it? Yes. Should you? No. Unless you had some weird funky number here. Instead of a to the 2 was a to the 25 or something. You don't want to write down a times a times a times a times a. Holy crap, right? It doesn't really save you much. This will evaluate like this. A times a, because we're using order of operations. It's going to evaluate. And then it's going to do b times b. It's going to evaluate. Then it's going to add them together. And then it's going to pass that to the square root function. That's what it's going to do, right? Again, I don't want to use this. A better way to do distance calculations a lot of times is to use something called squared distance. Squared distance. Where we basically say c squared is equal to a squared plus b squared. Okay? So maybe what I could do is, instead of calling it ABC, let's rename this stuff. I'll say A and B, right? And we'll say that C, we'll make something called C squared, okay? And we'll say that A and B, this is very bad. I prefer you to do it this way. If you're going to use A and B in this case, make it so that each line is separate like this. This is much better and more visible. A is equal to 3, and B is equal to 5, right? And then who knows what C is off the top of your head? There's a special magic triangle that's here for C. What's C? What is C? Just without doing square root. There's a special triangle I'm making here.
On the longer side, or?
It's 3, 4, 5 triangle. Actually, it's a magic triangle. So C is 4. Without doing square root, it's a 3, 4, 5 triangle, magic triangle. There's a lot of magic triangles out there. All right, so then I can simply say that c squared then is equal to a squared plus b squared. So you can avoid square root altogether, right? And why this is good is because c squared, if you have everything squared, if you're using the squared distance for everything in your game, you never have to use square root, and therefore you never have a performance hit per frame. Okay? So lots of ways of doing things, guys. Lots and lots of ways. You don't have to do things the one way. In math and in computers, right? There are multiple ways to express the same thing. Okay? That's the message here. Okay? Questions around what I'm talking about here? Is anyone confused? Please speak up now. Yes.
I'm just confused. I can't type as fast, so I'm just not.
I'm sorry. There's some great typing courses online, right?
I type like this.
And I highly recommend you guys learn how to type. As programmers, if you're going to be a programmer and that's going to be your skill, learn how to type. Touch type. Don't look at the keyboard and do it. There's lots of programs out there that'll help you do that, and you can be much faster. It's a bit of a protocol. You can practice every day, and you'll get better and better at it, and faster. You'll amaze your friends and even your enemies. All right, let's move on. Questions around this? I've talked about input and output. I've talked about declaring. One thing that we can also say is when we're assigning, we're also setting the variable name. And sometimes there's a funky word called mutate that we can use too, mutating. We can mutate the value of a variable by setting it or assigning it. That's what we're saying. When we're getting the value of the variable, we're reading it from the variable. We don't change it. We're just reading it, or we're getting it, or we're accessing it. Those are all the same words. Getting, accessing, reading. We're just reading the value of the variable. We're not without changing it. Okay? We don't change a variable by getting its value. We only change it by setting it, by using the assignment operator. Okay? That's important to know. Okay? Notice that this is repeated text. In the future, we're going to avoid repeating this over and over again. This is inefficient. This is inefficient. I'm doing the same thing twice. If in the future you see me doing the same thing twice, say, Tom, you're repeating yourself, right? Right now, we don't have tools. I haven't given you tools to not repeat yourselves, right? But in the future, we're not going to do this anymore. Yes?
I just gotta go wash my hands.
All right. So moving on, right? Then what we're going to see is we're going to see that I've given you examples in the PowerPoint. Please read the PowerPoint. This PowerPoint is for you, okay? It's not for me. I've written it for you so that way, skim through it later today so you understand the stuff that we've talked about here in class. It's going to provide you context in more detail. I've taken time to make this, and I'm making them every week like this, right? So it takes time to tell you about what this stuff is. Please read it. There's no textbook required in the class, but I want you to consider my PowerPoint slides like a textbook, all right? I need you to read it, all right? So this way we have the same language when we talk about things, all right? Otherwise, I'm going to say stuff and you're going to be like, what does he mean? What does he say? I want you to understand me. So that's what I'm saying. We talked about integers, and there's different integer types. I want to just fly to this area here and discuss this, right? What integers do. It talks about here how you can assign one variable to the other like this, right? We talked about that. One variable like this will evaluate. A will evaluate to a number and then assign itself to B, right? Evaluation happens all the time, right, in an expression. And I talk also here about tricks and conventions like what I just talked about right now. This is bad, right? This is better. Right? And I even give you some thoughts here. We don't have a quota on how many lines used in our code. Use whatever lines you need. Make it clear for yourself. Don't try and make it like one line of code. There's people out there, they're like, hey, I can write one line of code and I can do like stuff that you might be doing 10 lines of code. And I'm like, woohoo, who cares? Right? It makes no difference to me. All right. So other things too, like for example, taco and taco, underscore is okay to start with a thing, but one taco and star taco are not okay when you're declaring a variable. Variable names count. You can't use numbers in white space. It's not possible. They're all banned and stuff like this. Like for example, taco Pop-Tart is not allowed because the dash might be interpreted as a minus, like you're subtracting taco from Pop-Tart or something like that, right? Doesn't make sense. All right, and I kind of talk about here variable name conventions. Please read this. It talks about stuff. There's some things that are like in red, like don't abbreviate or remove letters. Don't do that, like player score. That doesn't make any sense for me. Or the worst is PS. That's terrible, right? Type system. We talked about types, and here are some integer types. Now take a look at that integer that we talked about earlier. Integers by default are very big. 2,147,483,647 on both sides, positive and negative. It's massive, right? So you can also do an unsigned int where it combines those two things, those two spaces, and puts them together to 4,294,976,295 as the biggest number you can ever do if it's an unsigned int. That's the type, uint, right? There's also a ulong. So there's an int and a long is actually a very long integer number, a very big number. So why am I showing you this? Because sometimes we have a need as programmers to represent very large numbers, very, very large numbers. Like for example, the distance between here and Alpha Centauri, right? It's a very long number, right? It's approximately 4 light years away. Each light year being the time it takes for light to travel there, where light travels 300,000 kilometers per second, right? So how many seconds in a minute? Multiply that by every hour, multiply that by every day, multiply that by every year, and you're going to get a very large number, right? Much larger potentially than this, right? So again, ulong might be able to represent the distance in kilometers, as an example. If it's a u means unsigned int. Okay, so representation is important. Okay, so again, we use int, but for age, we could probably have used a byte. So a byte has no negatives. It goes from 0 to 255, right? And a byte would have been okay for age because we're only going to take in, right, maximum, we're not going to be 250. I don't know anybody who's 255 years old, right? So, I mean, it's pretty good. Bytes are really great for things like what else? What else does this remind you of? 0 to 255. Color. 0 to 255. Bytes are a great number for this because they're colors, right? And so this is good. But you're going to see a lot of times that people are going to use integers because it's easier, not because it's better or more efficient, right? But if you talk to Connor, and one day you're going to, I'm not sure if you're going to meet Connor this semester, but he's a guy who does graphics programming and other things. He'll tell you that bytes better, more efficient for graphics programming, okay? So there's also other things like S byte, which is basically a signed byte, which is minus negative 128 to 127, which is the same number, 255 spaces, but divided by 2. All they're doing is half of it is negative and the other half is positive. Same number, right? And that's what these numbers are. They're just representations of numbers, okay? We talked about strings. We talked about characters today. And there's one more thing we didn't talk about, which is this funny representation here, hexadecimal Unicode. Woohoo, right? So sometimes you want to represent a symbol that does not exist with your keyboard, right? For example, if you come from Brazil, you know, you might have like an accent you want to represent, and it's not on your keyboard, so you can use a Unicode character here instead, right? A character that represents the character that you want to print out on the screen, right? Or an emoji or something else like that. Okay, so here's an example of that. \U says I want to use the Unicode number to represent my character. In this case, \U0061 represents an A character. Okay. By the way, for those who are interested, and I'm just going to pull up Chrome for a second. I don't know sure if you guys have ever programmed on the web, but if you haven't, it's okay. There's a really great font library called Font Awesome. Okay, let me show you this for a second. Okay, it's related. I swear. Okay. So here's Font Awesome, and you can look at icons for Font Awesome. And if I look at the A icon for Font Awesome, right, and I can also look at Font Awesome Free, so I can see here's the A icon for Font Awesome, right? And if you look at the top, it gives you the Unicode character for A from Font Awesome. This is Unicode, all right? So it'll give you this alpha character for Font Awesome, right? But it'll also give you a bunch of other symbols, like for example, this symbol right here, this arrow symbol, and for Font Awesome, it's Unicode, so \U F061. So why am I showing you this? Because Unicode is used all over the place, right? It's used to represent symbols, not just characters, and that's why or not just regular alphanumeric characters, and that's why we use it. All right. So you might see that here and there in your time as a programmer. All right. So that is text and strings. We talked about that, and floating point types. I only showed you float and double, but there's another one, right? Decimal. Notice that floats are single, double is a double representation, and decimal is a quadruple decimal representation. It can hold massive decimals, like really massive. Again, really useful in science. If I want to, use something like I want to calculate the gravity of a planet, I'm going to use the gravitational constant of the universe, right? 6.67 times 10 to the negative 11. Don't ask me how I know those things, right? And multiply that by, the gravitational constant, right? The gravitational formula to come up with gravity. You need to be able to represent very large floating point numbers as well. Decimal is also an option for this, okay? Also for banking. If you guys ever work in the banking sector, we need to be super accurate, so we use decimals for that as opposed to doubles or floats because they're not accurate. Imagine like those rounding errors we're going to get, especially for very large numbers. All right, so that is decimal representation. We talked about those. And there's some options here. You can also represent it in scientific notation. Here's a way of doing this. 6.022 times 10 to the 23, which is Avogadro's number, by the way, right, is you can represent it like this, right? Or you can represent it like this with an E in the middle. Right, so 6.02 E23 is the same as saying 6.022 times 10 to the 23. Okay, same idea. So you don't have to put in all those extra digits, those zeros. Okay. Booleans, we didn't cover. Booleans are truth values. They can only represent true and false. This is great where I have a character, right, who is either hurt or he's not. It's a binary state in many ways, right? Is the door open or is the door locked, right? True or false? Is this check mark on or off? Is it checked or not? Is it true or false? That's why we use this a lot. And Boolean, we're going to get to this next week when we talk about conditional statements, like if statements next week, right? It's a key thing that we're going to be using in our coding because we're going to say things like, did you collide or not? Did you get shot or not? Do you have ammo or not? True or false? All the time, right? We use this constantly for everything that we do. Okay. Just a couple more things here, and then I'm going to do other things. Type inference. So one thing that we've done here, let's go back to our code for a second, guys, right? I've kind of stated, like, this is explicitly telling the computer what I'm doing. But we don't have to do it this way. We can say something like var my age, right? And that's equal to 20. And that's also okay. Var my age is equal to 20. So if you know JavaScript or if you know other languages, you might say, well, var means variable, right? And JavaScript is loosely typed language, means they don't care about type at all. That means I can assign it, 20 now, and I can assign it like Tom later, and it doesn't matter, right? Not so in C#. C#, what it does, this is called type inference. We'll type this in. It's for you guys. Type inference, right? Also, what this is implicit typing, right? That's what this is. Implicit typing is the system will figure out the type for you. And it's really based on what I'm assigning. So if I'm assigning an integer, suddenly this becomes an integer. And if you hover over, it says int my age. I didn't say it's an int. The system figured it out from what I'm assigning to it. Okay? So var is also a valid way of doing things. However, I'm just putting it out point this out to you. You can't change this. You can't say that my age, okay, because we haven't defined it, is equal to Tom. This is a syntax error. You can't do this, right? Because my age has been, when we assigned it 20 the first time, it kind of figured out that it's going to be an integer. Now, here's positive and negative about this. Sometimes the system will get it wrong. Okay? Here's where it can get it wrong. Where if I say my age is equal to 20.5, right? As an example. Then what variable is my age? What type? Tell me what type it is.
Float or double?
Float or double. Okay, but what do you think? Give me one of them. Which one is it?
I think float smaller.
Float smaller, but what, for me to indicate it's a float, what do I have to do?
For it to be a float.
So it's a?
Double.
Okay, let's hover over and see what it says. Double. You're correct. Okay? And if I put an M here, like this, what does that mean? If I hover over, then what does this tell age? Age is now a decimal, right? Which is massive. M stands for decimal, unfortunately. That's what it is. It's not a D, right? You might think it might be a D, but it's not. It's an M. M means decimal. And decimal is that 4 times larger thing that we don't want to use, right? Unless we actually absolutely have to. But that's what it does. It kind of figures this out. Whatever we assign to it, it knows. Here's something you can't do with typecast. You can't do this, right? Why can't you do this? I haven't assigned anything, so what the hell am I doing here? It's nothing. I'm not assigning anything. I can't do this, right? I must assign and declare on the same line if I'm using var, and that is a disadvantage sometimes. Okay, so var is great, especially if it's a very long, complicated data type, right? That it requires a lot of stuff. You don't know what it is, right? A good use of var might be something like my age text is equal to a console read line, right? If you don't know the type that this is going to be, you can just hover over and it's going to be a string. Okay, that's okay. Because if you don't know what this is returning, it's going to figure it out for you. Okay, as opposed to me having to type in string, you can do this too, string, string, there we go. Okay, now take a look at this. It didn't complain much when I had it as a var, right? When I went to var, it was fine. It didn't have that little underline here, right? But now when I went back to string, which is what it is, I get this line underneath here. Remember what it said to you when you hover over, the warning that it gives you. It says, converting null literal or possible null value to non-nullable type. That's the warning you're getting. And I know it's a complicated warning, but what this means is the user could enter nothing. That's what this means, right? So if you hover over, what it's asking for is for you to do this. Okay, this is advanced, but I'm telling you this in advance so you know what this is. This means I may or may not get a good value. That's what the question mark means. I can't tell you, compiler. I can't tell anything for you, Visual Studio. I might not get anything here. I'm telling you it's okay, though. I know that I may not get anything here. That's what that question mark says. Okay? Just FYI. If you see this, it means I may get the right thing or may not. Okay?
What does it do when you do that?
It just means it takes away the error, but it also basically says that my age now is a variable that might get nothing. I might not have anything in there at all at the end. Okay? And if I hover over and I make this var again, right? That's exactly what var does. Var sets it as a string with a question mark at the end, which means I don't know what I'm going to get here. I may get a valid string. I may get nothing. That's what that means. Okay? The other way sometimes we might see it in other programs is this exclamation mark, but it does not exist here in C#. Okay? All right, questions around type inference. Type inference being using the var keyword. All right? The var keyword can be helpful if it's used for complex types that you don't know what they're going to return. You can create variables and they're not so bad, right? But var won't work on its own. It has no clues to facilitate this type inference, is what it is, right? Okay? This is a good use of var. All right, let me just continue now. I'm moving to type conversion. We talked about the convert class, and I converted to int32. We did that also, right? And here is a bunch of convert to whatever, right? 2 byte, 2 int16, 232, 2 character, 2 single, 2 decimal, all right? 2 single is a float. 2 decimal is a decimal. Where's the 2 double? Right? It's right here. 2 double. 2 Boolean. Right? These are all the conversion types that are built into C#. So you can convert from one thing to the other. Right? To string. Look at that one. Convert to string. And I can convert a number to a string. This is also very valuable. Right? Where I have a number, but I want to represent it as something else, and I want to represent it as a string, I can convert it to a string. Okay? By the way, every time we do this, we put a number in console write line, it does this implicitly. It converts to a string for you, right? Because it's converting it and sending it to the write line, and it's converting it to a string. All right, so that's the conversion class. There's also something else, which is older, called parse. Okay, it's out there as well. And some professors that you might see in the future or some places you might look on the internet or whatever, might use parse instead. So what this looks like is if I want to int parse, my number, right? So if I say something like int.parse, right, my age text, that's valid. Okay? What I'm trying to do is I'm trying to parse it, and which is it's converting the string representation to a number. I personally don't like parse. I like convert. It's very simple. Convert to this. Convert to that. Parse, meh. It's kind of a weird name, and some people don't understand what it is. So for students, this is, if you want to do this, you can. You can also do a float.parse, right? That's also possible. You can parse it as a float, right? And there's many other ones that you can do, right? You can parse all those different kinds. Now, whenever you parse it, it returns something, right? So this one returns an integer. This one returns a float. This one returns a double. And then you'd have to have some kind of declaration, like, for example, var my age integer is equal to this. Var my age float is equal to this. And var my age double is equal to this, right? And you can see that when I use var here, and if I hover over, it tells you the type. So that's an integer, right? That's a float, and that's a double. Okay, so that's a good use of var if you don't know what you're getting back. But I prefer not to use parse. I don't like this. I would rather you use convert. Convert is the better way to do it. Both do the exact same thing, by the way, for the most part. Okay, make sense? There's two ways of converting. You need to convert sometimes from a string to a number, or from a number back to a string. And that's why we do these things. Okay?
Is there a computational difference between the two of them?
There probably is. But it's not required for us to know.
Okay.
It's probably small enough that we're not going to do it. Now, if you do a lot of conversion in every frame, you got to consider why you're doing that.
Okay. Yeah, because
Okay.
I am one of those people who uses parse.
Okay, no problem. I'm not sure. That's the answer. I think they're equivalent.
Okay.
I think convert is just another way of doing it. I think they've moved to the convert class where integer uses the primitives. So actually, maybe parse is faster. Maybe. Okay. Let's go back to this. So parse, we can do this for sure. And let's go back to operators. We've learned about operators, right? We've learned about equals. That's the assignment operator. But there's also the plus operator. This is new. Okay. So we can say that whenever we have an operator like plus or minus, these are binary operators. Binary operators are where we need two operands. Okay. Let's go do it here and stuff like this as well. So here's something that's valid. If I say var my number, this is a bad variable, my number is equal to 2 plus 3, right? That is valid, right? Right? And what I'm getting is plus. The plus is, if I hover over, it tells you. I'm using the int operator plus. Look it tells you right there. The left side is 2, and the right side is 3. That's what it's doing. It tells you right there what it's doing, right? So plus is actually an operator, right? And so is minus. So if I was to change this to minus, right, you can see again, if I hover over, it's minus. The operator minus is what I'm doing, right? 2 minus 3, okay? There's also multiply. We saw this earlier, right? And there's also divide, okay? Now, the one thing you have to worry about with divide is dividing by 0. So if you ever have this scenario here, that's a divide by 0. It gives you an error right away, right? And the reason why this is a problem is because this is undefined for computers, right? If you do something like this, because 2 divided by 0, if 2 is a variable, an integer. But if I do something like this, it's not undefined. It's not an error. Yeah. This is actually valid, right? This is actually positive infinity, right, is what it returns, right? And that's what's going to be stored here, right? Positive infinity. And there's also negative infinity. Here's negative infinity, right? That's what it's going to define as. Why? Because floating point numbers, remember, the real number system is infinite, right? The numbers between the whole number 1 and 2, there's an infinite amount of numbers between those two numbers, right? Infinite. So because it's infinite, when I divide infinity by 0, it's positive or negative infinity inside from a computer perspective. Okay? So keep that in mind. It's different than if I use an integer. If I was to use an integer like this, right? That's an error. That's undefined. We don't know what you mean there, right? How do I take an integer, a whole number, and divide it by 0? Right? Doesn't make any sense, right? So be careful of division by 0. Division by 0 is something that is going to have a problem. It even tells you this. Division by constant 0, that's terrible. It doesn't compute, right? So that's a problem. Okay, but what about if I do something like this? If I have my number, and if I set it to 2, okay, and then I want to make this number bigger, okay, I could do something like this. My number, right, is equal to my number plus 1. That's valid, right? My number is equal to my number plus 1. When you see this, people get confused. Students get confused when they first see this for the first time, right? Because they're like, wait, what does my number equal to my number plus 1 mean? Does it have a meaning, right? Well, remember, what is this doing? This is an expression, my friends, right? So what it's doing is, let's evaluate this expression. So what is it going to do? It's going to take my number, get the value of my number, which is 2, and then add 1 to it, and then evaluate those two things. 2 plus 1 is 3, and then it's going to assign it back into my number. So my number becomes 1 higher. My number is equal to my number plus 1. This is a very common pattern in computers. Here's something. Health is equal to health plus 1. That means I increased my health by 1. Level is equal to level plus 1. Right? There's a shortcut to this. There's a shortcut to this. Here's the shortcut. Ready? My number plus equals to 1. This is equivalent. This, right? These two lines are equivalent. Okay? This operator, if I hover over, it's actually a special operator. It's the shortcut operator. That's what this is. These two combined things here, this is the shortcut operator. It doesn't tell you here, but it is. It's basically doing this exact same thing here. It's saying, take my number and add 1 to it. That's what this is. That's what this is. Plus equals. You're going to see that. By the way, it exists for minus equals, times equals, and divide equals. Okay, and all those things, those shortcut operators. Okay. One more way of doing things. This actually is called incrementing, right? That's what this is called. I want to increment my number because what it means is, adding or increasing it. That's where it comes from. Increasing the number. Okay, increment. That's a special word in computers. Increment, right? There's also decrement, right? So if I do something like my number, is equal to my number. It's trying to guess what I want. My number minus 1. That's decrement, right? Which means decreasing, right? And I can also write that like this, the shortcut. Those are equivalent. These two lines are also equivalent, right? Okay? Does that make sense? These two lines are also equivalent. There's one more way of incrementing or decrementing, okay? And that is using this notation. My number plus plus. And my number minus minus. Now these are all incrementing by 1, okay? Very common. But you can also increment by 2. Now this pattern, okay, increments by 1. That's what this does. And this is using the suffix, okay? Suffix decrements. And I'm using suffix for a reason, right? Means that the plus plus operator or the minus minus operator comes after the variable. That's why it's a suffix. But there's another way of doing this, which is the prefix. So you can do this too. Increments by 1, and this is prefix notation. Okay, and the same thing goes here, where I want to use my number. Oh, sorry, minus minus my number. Right, which is decrements by 1, and this is prefix notation. Oops. So different ways of doing it, and they do the same things, right? So why am I showing you all this? Because we do plus plus and minus minus all the time. That's why. We don't really use it in an expression. That's normally how it's not used. It's used in a loop. Right? That's when we use it mostly. When we're looping, we're going to do something over and over again, we use plus plus a lot of times. So number plus plus. Plus plus number means something different. All right? What do you think the difference between these two notations are? So what this does, if I use this, is it evaluates this first. That's what it does. It evaluates the number first. So let's say, for example, the number is 2. And then what's this number now at this point? Let's look at these numbers, these things that have happened here. So number is equal to number plus 1. So it starts at 2, and now at this point it's 3. Okay? And what about here? It's 4. Okay, here it's 4. Right here it's 4. And then plus plus. Now it becomes 5. Here it increments it first and then evaluates. It's 6. And then it evaluates everything. So this plus plus, something plus plus, or plus plus something, is when it evaluates. First I evaluate the variable here. First I increment, then I evaluate the variable. Okay, so 2 different ways of doing things. They're mostly equivalent for our purposes, but it really depends on when you want to use them. It's the same thing for these. Okay? And let's go to the bottom. So if this is 6, and now we're going to subtract 1, it's 5. This is subtract another one, it's 4. This is going to subtract another one, is 3. And this is going to go back down to 2. Okay? You can see how this works. Now remember, you don't have to just add 1 to it. You can add 2, 3, 4, 10, 20, 50, 100, whatever. Here is only ones up and down. This goes only up and down by 1. But these, you can put whatever number literal you want in there, and you can make that whatever you want. 20, 30, 50, 100, whatever. Okay? Questions around this. So this is incrementing or decrementing. When students first look at this, they're like, it's hard for them to get their head around because they're like, wait, you said, Tom, that the equals operator is an assignment operator, and then what am I assigning to number? Well, first we're evaluating this, the expression, and then whatever this turns out to be, we're storing back in here, right? And so this is just a shortcut of this, right? That's what this is, okay? So first we evaluate. We take the expression and convert it, and once we've converted it, then we assign it with the assignment operator. Okay, that's what we're doing. Keep that in mind. Back to this. So I've talked about this. I've talked about how to do stuff with basic math and operators and expressions and all that kind of stuff. And you can see here where we talk about bed mass and division by 0. Okay, and a lot of more operators here that we talked about before. One more thing that we didn't cover is the percent. So there's one more operator called mod. So if I do something like, let's do this. If I say something like the remainder, we'll call this integer, or sorry, we'll make it a float. Float remainder, right, is equal to, 5.2% 3, right? So that's what we want, and let's make it so that it is proper. We'll use F to indicate all that. So what is this percent? Percent is not getting the percentage. Percent is saying, take 5.2 divided by 3, and then whatever the remainder is, assign it to here. That's what this does. That's what the percent is. It's the remainder operator. I also call this thing, and you might see it as the mod or modulus operator. All right. So the modulus operator, that's what this thing is. So this is the remainder or modulus mod operator. Okay, that's what it is. Modulus operator. Why this is good? Why do we care about the remainder? Right? If I want to find out if something divides evenly into something else. Example, if I want to know if 8, 6, 10, 12, 24, does it divide evenly by 2? So increments of 2. If it does, what's my remainder going to be? 0. So I can test to see if it's a remainder 0. If something divides by 2 and if I get remainder 0, which means it's even. I can test if it's even or not by just doing that. Is it even, or is it divisible by whatever number you want? And this is really great when I want certain increments. For example, I want every 3 increments. Is it divisible by 3? I want to kind of like count every 3, right? If it's divisible by 3, I'm going to get 0 as the remainder. So for example, 9 divided by 3, right, is 3. With remainder 0, right? So therefore, 9 is divisible by 3. Okay, that's how we can use this modulus operator. If it's, we can test to see if something is divisible by another number, right? By the way, here's something else. I can do it like this too. As long as one of the two operands are a float, then this becomes a float because it converts this one implicitly to a floating point number. Okay. Back to this. So that is what we talked about. We talked about pluses and minuses, postfix and prefix kind of thing. And there's also one more thing we got to talk about, which is casting. So sometimes what we want to do is we want to explicitly cast something to something else, right? Casting has been around for as long as I've been around, okay? And it came before conversions, all right? So here, if we have situations where if I want to convert a float to a double, I have a floating point number, half precision, and I want to convert it to a double precision number, no problem. Why is that? Because my floating point number is less precise than the thing I'm converting to. That's okay, and it's automatically done. No need to convert, right? But if I want to convert a double into a float, man, what's going to happen to all those extra digits? They're going to be lost. I'm going to truncate. That's what it's called, right? So if I try and convert a number of a float to a double, we'll call this double remainder, right? And I want to say something that equals to remainder, right? Notice that there's no problem doing this. If I have a double remainder and I want to go from a remainder, which is a float, to a double, no problem. But if I want to go the other way around, so if I want to go something like this, float my remainder is equal to double remainder, I'm going to get an error. Why? I'm trying to go from a much more precise level of detail to less precision. And that means that I'm going to lose digits. So I got to tell the compiler, this is what I want. It's on me. Don't worry about you. You didn't make a mistake. It was my mistake. I'm telling you to do this. And the way to do that is to use casting. And what we can do with this, we can say this is a float. That's a way of doing it. That's called casting. And this is the old school casting methodology that we use in C, C++, and a bunch of other places. Casting. So I'm casting this double remainder as a float. It's explicitly telling the compiler that it's okay if you lose data. All right, that's casting. So this casts a double as a float, right? Casting. Okay. We talked about math classes, and now console 2.0 really quickly, and then we're going to get into our in-class exercise so we can finish it for the afternoon, okay? Before the afternoon. Here we go. So we did console write. The write method doesn't kind of go to the next line. We did console read line. We also have something called read key. So for example, press any key to continue. We can do that with read key, where it can wait for a key, right? We also have changing colors. So here's something that I want you to try. Let's change our color background to a yellow or a black, yeah.
Hey, changing the background color? That's what I did before.
Hey, that's cool. So console colors, you can do that with background color and foreground color. Foreground will change the font. Background will change the background, right? And we can also do the clear method, where we can clear the console, right? So here's something that we can try. If I was to, this doesn't do anything, by the way. My little code here, all it does is, we care about this stuff, right? Let's try this out. So if I press play, it's going to basically go, it's going to evaluate all that stuff. It's going to say, okay, here's my name, Tom, right? And my age is 20. And then it's going to say, Tom is 20 years old. And then it's going to just hang there for a bit, right? And then it's waiting for me to type in something like Tom, right? And it's going to crash because what it's trying to do is evaluate my read line statement. I never prompted the user properly, so I didn't know what it wanted. It's going to convert, it's going to take this string and convert it to an integer. Oh man, this is bad, right? My bad, I programmed this, right? Let's try this again. And this is it might, when you see the thing like this, it's actually giving me a breakpoint. This is where I've broken my code, and it tells me what the problem is. System format exception. The input string Tom was not in a correct format because it's expecting it to be a number. That's what it's expecting it to be, okay? When I'm parsing it. So, so that's definitely something. But what if I cleared the screen? So if I went all the way to the top here and I cleared my screen, so let's say before I converted, and let's just get rid of all this other stuff. This is all for your practice and knowledge, right? But we don't need any of it. So if I want to keep it, but not have it in my way, I can just comment it all out. So I can do something like this, right? So kind of a /* and all the way to the bottom. Before these curly braces, I can put the other one, right? Oh, and now all of this stuff we did, this is for your learning, is here, but it's commented out. It doesn't take any effect. Remember, the compiler ignores comments, right? So now if I run it again, you can see that it's just going to ask me the same questions, right? And it'll just stop after that. It won't do anything with the stuff that I've got commented, right? So if I want it to print out this, then I have to uncomment it here and comment it down here. So now it'll actually print out what I just typed. So let's try this again. So I just commented it down. I just moved my multi-line comment start to here. This is the start of my multi-line comment. So now I can do this. Let's try this again. Okay. So again, I'm going to say Tom and 23, and then you can see Tom is 23 years old. But I want to get rid of all this crap, right? So, or can I? Not really. What I can do is I can clear the screen at the beginning. So I can do something like this. I can say console dot, and I want to, if I do clear, that actually clears the screen. So console clear. Okay, so let's try that out and see what happens. Console clear, again, it clears the screen. There's no difference, okay? And then I can use some colors. I can say console, right? Here's console dot background color. And I can say, let's make it green. I'll accept that. And this will do a console foreground color. And we'll make that red, sure, Christmas colors, no problem. And let me just try that out and see what happens. So let's do that one. And you can see now I've got this, right? Please enter your name, right?
I'm still having trouble commenting them out loud.
I know, right? You can always erase everything. It's on my video. It's in my video. You don't have to keep it, right? So that's kind of interesting. You can do that. What about if I clear it instead? So first I change the colors and then I clear it. What if I did this? I move the clear down after I've done the color change. If I do that, then you're going to see that you get this. Okay? So all I've done here is I've just moved the clear after my color changes. Okay? So I can change the color as well. Okay? And this color is really annoying, and I can choose other colors that are better. Like, for example, maybe I want to do a gray color, gray, and maybe I want to use white. You know, that's not as bad on the eyes as what we just saw. So I can do that. There's my, well, that's just as bad, you know, in some ways, because it's too bright for me. Right, maybe it's dark gray. Is there a gray, like dark gray? Yes, there is. Dark gray and white. There we go. You can do that, and you can try that color out. That's better. I like that more, right? That's better. And you can see now that I've played around with the console, so it looks a little bit nicer, right? And so there's those kind of commands as well. Okay, good. So color and background, we talked about that. And window title, you can change that too. So you can say that the title of the window, console.title, you can set that to a string, which is like my character sheet. Here it is. There's that. Okay, so I can press that out. Console.title, and at the top, now it says character sheet, right? The console title, right? At the top, see? Character sheet. And all I did was change the title. So I can control my console a little bit more, all right? Which is pretty cool. I can also get the beep method, which is kind of cool. I can set up this beep method. I'm not sure if you've seen this, maybe if you know this, this thing. I don't know if it'll even do it for me here because I'm on the school computer. But I can kind of put that in and play that too, right? And see what it does, right? No, you can't hear it. But it actually does the Mario theme, if you can try it out, and, you know, just a bit. So beep methods are kind of interesting. I'm not sure how useful they're going to be, but basically you do console.beep, you have a frequency for the note and how long you hold it in milliseconds. And you can make whatever notes you want here as well. And this is, again, is a little tune. Thread sleep basically means wait. That's what it means. Wait, don't do anything for this many milliseconds. So it's like a pause or a silent note, if you will. And you can kind of create some simple, weird things with this as well. So console beep is something that you can do as well. And that is the beep method. And we did already string interpolation. Okay, so what I want to do with ICE2, right, is I want to do this. Okay, we've already done our app. I want to do get init. Let's do this really quickly now. I may run a little bit over time because of our power outage, but it is what it is. And I want to start this off. Okay, ready? Let's do it together. So what I'm going to do this. You can keep your comments. Just comment your stuff out. But I'm actually going to work to make this thing the way I want. I'm going to just kill all this, everything here, right? And so now here we are with our first thing. This is what I'm going to do first. Okay, so this is the first part I'm going to do. I want to put this up on GitHub, and I want to share it with you so you can see it on GitHub. So how do I do this? Well, remember last week at the bottom right corner, and since I'm recording, I'm at the bottom right corner. I'm going to move myself over here so you guys can see the recording on the bottom, right? But the bottom right corner of Visual Studio has this add to source control thing, okay? Let's do it. Let's add to source control. And it says Git. There it is. So what this does is it says, what kind of Git repository do you want to make? I want to make a local repository only. That's what I want to make. And then I want to click Create. Awesome. Okay, so I made my local repository. What this did is it used Git init. So if I go back to my in-class exercise, it actually did this line, and it also added a git ignore. That's what it did. It did those two things for me. Now, it also added my first commit, right, which is an initial commit or whatever. And the way to test this inside of Visual Studio without leaving it is to go to View, please do this with me, Terminal. View, Terminal. Okay? It will bring up this little terminal, and you can actually do something like git status, right? Git status. So it does little commands here. You can do all the commands right here. You can also do a git log or git status, okay? Git log actually shows me all the commits. What is a commit? Who can tell me what a commit is really quickly? It's a snapshot of the current state of your code. That's what a commit is. So here, it's Visual Studio has actually done 2 commits for you. It added your project files, and it added your Git attributes and Git ignore file. That's what it did, okay? If I press Q here, it kind of gets me out of here. If I just did a, again, you can see Git status basically says, hey, where are we? Git log shows me my commits. That's what it does, okay? If I issue a clear here in my terminal, I can clear the screen, okay? Now, what I want to do, because I've done everything nicely, I've initialized my repository here with Visual Studio, and I want to create a new repo up on GitHub. Yes.
Sorry, I missed the part where you created the local repository.
So on the bottom right, there's Add to Source Control on Visual Studio.
Yes.
Okay, click that, and then follow and click Git, and then it'll pull up a little dialog box, and then click on the left, Local Repo on the left. And then it'll do your thing, okay? All right, so back to this. So when we're here, local repo. Thank you for your help. You're awesome. So, and if you want me to show you that again, I can. The way I can do that, right, is I can close down Visual Studio for a second. Bear with me, so I can show you that whole thing again. And then inside of my ICE2, right, inside of my ICE2, you can see that I've got a hidden .git folder. The way I can see that is if you go to View, I can show you that file name extensions and hidden items are checked, right? And I can see my hidden .git folder. I can get rid of it, and I can start over. If I double click on my solution, my SLN file, it'll bring up Visual Studio where I left off really quickly, and you'll see on the bottom right, for people who missed it, there is an Add to Source Control down here on the right. I can do it again. Here it is. Ready? click onto it, press Git. It's going to ask me if I want to go local only. This is what I want to do. I don't want to add a README file. I just want this right here, and I want to click Create. And once I've done that, it creates a Git repository for me, a Git init. It does the first bit for me. Next, yes.
When I did that, it before just after pressing create instead of just like doing it, it had a box of like, do you want to save? Is that a problem?
No,
Okay.
because that means you haven't saved. I saved before, and so it's just asking you if you want to save. Saving is okay. Now I want to create a repository again. Remember last week we did it? Let's do it again this week. So this week I'm going to go to GitHub. There we are. And remember, I own Georgian College. So here I am with Georgian College, right? And I want to make a brand new repository here. Two ways to do that. I can press the new button, or I can press the plus button up top here. I'm going to press the new button. And then it's going to ask me what the name of my repo is going to be. I'm going to call this COMP1115 in the fall 2025 semester. And it's going to be ICE 2. And just to show you this really large, it looks like this. Okay, for you, you're not going to have Georgian College here. You're going to have your name, right? That's going to be your account. So please do this now. I want you to create a repository, okay? Hurry up, because we're timing out, and I don't want you guys to stay too long.
We'll have to add you to this one as well.
You need to add me to this one as well. That's why we're doing this. I want you to get experience using Git and GitHub, and I want you to do the same thing we did last week again.
Is there a way to add somebody specifically to just see them all automatically?
No. Unless we create an organization together, then yes. Or a team. But don't do that right now. All right, so here I've used this, and it has to say this. It should say whatever your repository name is available. Again, keep your repository name appropriate. Don't make some weird ass name. I don't want that, okay? And then once you've got this, please do not use any README file or change your visibility. It should be private, please, for you. So leave it as private. If it's public for whatever reason, please change it to private. Please do that. Change it to private, okay? And then once you've done this, at the bottom, click Create Repository, all right? Again, this is assuming that you already have, kind of signed up for GitHub last week. You did in-class exercise 1 or attempted to, right? And now you're making a second repository called ICE 2. Okay? Now, I'm private, but I want you to see my code. So what I'm going to do is I'm going to make myself public. Don't do this. What you should do instead is you should go to Settings, and on the left, you're going to see Collaborators, right? You're going to click on that, and of course, it's going to ask you to two-factor in, like me, most likely. So there we are. Once I two-factor in, then I can go in here and add people as to manage access. So if I click Add People, you want to find me, right? So please use my last name, TSILIOP, right? And you'll see only me as there. If you just use these 4 letters, okay? I'm starting to get people like Brandon. I got Allison. So you guys are doing the right thing. Keep doing it, all right? And once you've added me, I'm going to get a little email. Okay, there's Sam. Thank you, Sam. And a bunch of other ones that I'm starting to get. Here's Hayden. And I can see people are coming in, and Austin and Rebecca and a bunch of other people, Kamika, and they're adding me in as a collaborator. This is good. This is exactly what I want, okay? And then once you've added me in, I'll have access to your repository when I access it, when you put it up on Blackboard for me, the link, okay? So now, going back here, I'm going to change don't do this. This is for me to do only. I'm going to go and change my settings. That's what I want. I want to change my stuff to public. This is me. Don't do this. This is for me only, okay? And I'm making myself public because this way you can see my code. I'm going to share my repository with you on Blackboard so you can compare my code to your code, just in case something's wrong. For my part, the part we do together. For the part we do separately, you do, I'm not going to share that part with you, okay? So let's do this now. So now that we've got this repository, I want to connect to it. And the way to do that is there's some steering instructions in here. We've already done this part, my friends. Oh, up to here, actually. we need to do this part right here. We need to map a remote, add a branch, and push. So all I need to do in the bottom here is grab this code, copy it, okay, and go back to Visual Studio. Go back to Visual Studio. Make sure that you can see the terminal, all right? So I can go View Terminal right here. And if you did everything right, and you right-click, it's going to do this. Right-clicking in the terminal, if you copied it, will copy all this code in for you. You don't have to remember it, okay? At the end, though, the last thing you do, you have to press Enter. And if you press Enter, it should ask you to log in if you've never done this before, right? It might ask you to log in to Git for the first time. Make sure when it asks you to log in to Git that you put in the proper credentials, okay? So again, for these people who didn't see it, it's this. All I did was right-click, and once I right-clicked into my terminal, I got those commands from, one second, I got them from here. This is where I got them from this stuff. And if you don't see this, you can always go to Code on the top left corner to see it, and then it'll show you this. Now it won't show it to me now because I've actually put it up on GitHub. When you're done, if everything's good, you should see this if you refresh, okay, on GitHub. So check your GitHub. After you've pushed, you should see this. And this is your first commit. Are you with me?
What do I do if it failed?
Huh?
What do I do if it failed?
That means that there's two ways that it failed. One, you've added a README file for some reason by accident, and that's not required. Two, you don't have access to do that from here somehow. You didn't log in properly, or something else went wrong. What does the failure say?
SRC ref spec main does not meet any.
That means you haven't added anything. You haven't actually done git add dot. Okay. All right. So if you're here, everything is great. You put this up. This is your first commit, and in our PowerPoint, you've come up to this point right here. Okay. Now let's declare a string character name. So again, back to our Visual Studio. I want to do this with you, this part. So I'm going to declare a string called character name. String character name. Yes.
Okay, so I put down the log file. It says exactly what it should accept. Like now.
You're gonna have to wait till after. Let's wait till after class. If you wait around, I'll help you out. I got to move on. All right. So string character name. Okay, that's the first thing. And now I want to declare 6 integer variables for the character's primary attributes. So I could make a comment here like this. So primary attributes. Okay, and then inside here I can make my 6 integers. So int, the first one is agility. I'm using capitals here, but you don't have to, right? You can also do this. And then int strength, int vigor, int perception, int intellect, and then int will. Those are my primary attributes. And if you don't recognize these, it's okay. I'm making these up. I also want some secondary attributes. Here are the secondary attributes that I want. Ready? My secondary attributes are int awareness, int toughness, and int resolve. Okay? All I've done is defined a bunch of integers. That's all I've done here. One string and a bunch of integers. Are you with me? It's very easy. I'm just defining a bunch of variables, okay? The variables have no input right now.
Just pull back up slightly again.
There's nothing really up there except for this part, which is just like the background and that kind of stuff, those colors. So it's just this.
I need to write the character name.
Yeah, character name is what we need. So character name and all these. And what I've done here, if you go back, look, I've done this part right here. I've declared all this stuff, right? So now I need to add a commit message, added primary character variables. Let's see how this works. So if I want to do that, I want to go view. First of all, let's save everything, right? I want to go view, and I want to go to terminal, right? And in the terminal, I want to type in, here are the commands, ready? Git add dot. Git is the program, add is the verb, Dot is what I want to do. I want to add everything. That's what this means. Git add dot. Let's press enter there. Okay? If it doesn't error out, then it's good. That's what it means. There's no feedback that it's positive. All right? There's only feedback that is negative if something goes wrong. Okay? Next, git commit minus M for message, and then what we said there, which was added primary character variables. So we'll do that. Added primary character variables. Okay, and press enter. So that's the commit. So those are the two things: git add, git commit. Git add, git commit. Git add dot, git commit. All right. Git commit. I know I'd like to make it bigger. I don't think I can. I've tried to make it like bigger, and I wish I could. I don't think there's a way of easily making this like much larger. I don't know if there's any way. Extensions, imports, and extensions, keyboard.
Enter, it said, oh, I spelled it wrong.
Aha.
That's my problem.
Aha. Source, text editor. Yeah, that's the text editor. These are settings for the text editor. I wish there was one for the terminal that I don't know of. I probably don't know. There's probably one for the terminal as well. But anyways, what I want is the terminal to be larger, and of course I can't. I can't zoom in. There's no way to zoom in for this one. All right, so now this is good. So that's what I've done. And notice that I've done those two commands: git add dot, which basically marks everything that I've done as my commit. I made my commit message, and now I want to push. This is the next command: git push. Git push. Git push, guys. Yes. Yes, I see it.
It's not. It does. It says added primary character variables did not match any files known to Git.
Yeah, you have to do git commit minus M, and in quotations, added primary character variables. Yes.
When I do the git commit M,
Uh-huh.
I get on branch main, and then your branch is up to date with origin main. Nothing to commit. Working.
That means did you do a git add beforehand?
Yes.
Okay. So that means that you haven't changed anything. Maybe you already added these in. I don't know. But maybe you have to save.
Huh.
Yes.
It does not say the same thing that you did. It says on branch master, nothing to commit.
Yeah, because you didn't save. Save first. All right, and then I'm going to press push. And what push is going to do is going to push me up to GitHub. Once I press push, if I go back out to here, and if I refresh now, you're going to see that I have two commits, right? Here's my second commit. And you can see that my second commit says added primary character variables, right? That's my second commit. And if I go into the in-class exercise and look at program.cs, you'll see everything up here. That's what you should see on in-class exercise 2 up on GitHub at this point, okay? Last part for me is console input. I want to use something called math clamp. Math clamp. And what math clamp is going to do is it's going to clamp the value between 5 and 50. Clamp, what it does is it limits your input from 5 to 50, a range. And if you don't get that, if it's lower than 50 or higher than 50, it'll be 50. And if it's lower than 5, it'll be 5. That's what it's going to do, 5 to 50. So how can we do this with prompting 6 times? Well, we have to prompt that inside of our here in this place. So let's prompt for input. So prompt for primary attribute input. Guys, I'm almost done. Please bear with me, and then I'll let you guys go. All right? Here's how you do that. All right? So you do a console dot write, where it says something like enter agility. Yeah. Okay, console.write, enter agility, and you want to do something like this, and then you want to do a agility equals to math.clamp. That's what I want to do, and I want to type in something like whatever I get into agility and that kind of stuff. I want to be able to clamp it. Okay, I'm going to leave this in a second. Okay, let's go to the next part. I want to do a console input, right, where I can say something like agility is equal to, right, convert dot, and I want to go to int 32, which is what I want to do, right? I'm converting, and I'm getting the console dot read line. I'm converting it to a integer, right? So this converts my input from, instead of using a temporary character, a temporary variable, from whatever it is in the string into a variable, an integer, right? That's what I'm doing here. And then what I want to do is I want to take, you don't have to record this, I'm putting it up on GitHub. And then I take agility, and if I put it in here as agility, math clamp, and I want to limit it between 5 and 50. So whatever it's going to give me, it takes agility, it evaluates it, whatever it is, and if it's lower than 5, right, then it'll become 5. If it's higher than 50, it'll become 50, and it'll store it back into agility. I need to do this 6 times. This is my first time. Enter agility. Let's do it for the other ones. And then I'll put it up on GitHub for you. So here's the second one. And I'm just going to copy paste a bunch of times, okay? And I'm going to change them in a second. I'm just going to copy paste them first, okay? Yeah, 1, 2, 3, 4, 5, 6. And I'm going to change the names. Instead of agility, I want to go with strength. So the second one is strength. So strength, strength, strength. Oops, oh, why not the wrong one? Strength. The second one is strength, 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 and strength. Okay? And I want to do the next one, which is vigor. So vigor, 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 vigor. And then I want to do the next one, which is perception. Copying it there. Don't be stressed. It's going to be okay. Perception, 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 perception. And then intellect. Just copy pasting here. That's all I'm doing. Right? And then intellect, 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 intellect. Do I have enough? Agility, strength, vigor. Oh, we have agility. We have an extra agility. Damn. Okay, I'll move this. I'll cut it. And I'll move this down here. And then I have will is the last one. So will. And then it's going to be will, 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 and will. Okay? So that's what this does. Will, 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 will. I don't need these. I'm not doing this every single time. I don't need these extra comments. I can take those away. Right? I can take those away. I only do that once. And you can see that I have nice 6 repetitions that look like this, right? Are you with me? I know I'm over time, guys. Please bear with me. Are you with me? This is like what I've done. Okay. And I can also add a fancy separator, if I want to, that looks like this. So I can do a console.writeLine. And I can do something that looks like this. Doop. Right? Just because. Right? I could do that. So I can do this, and that's agility, right? But I can also add in one thing that I haven't done is I haven't taken in character name. Let's do that too. I haven't asked you for that, but might as well ask you. So I'll say enter character name. I'll copy paste this to get it done. So enter character name, right? And then I do a console read line into character name. So I can say something like character name is equal to a console read line, right? So that, prompt for character name. Okay, that's what this does. So I've done prompt for character name. I prompted all this as an example, and then I can actually add another one of these little lines at the bottom, right? So when I'm prompting, I can kind of show you what this looks like this, right? And then this is what I have. Let's test it. Let's test this out and see what happens. Okay, I'm not outputting anything right now. I'm just inputting, okay? Let's try this out. So ready? It looks like this. Enter character name. So, okay, Tom, okay? and then enter agility. Now let's say it's 35. And then let's enter strength, 35. Let's enter vigor, 30, 30, 25, 25. And that's it. That's all I asked it to do. So far, that's my character. 35, 35, 30, 30, 25, 25. Okay? Numbers range from 5 to 50, right? That's what it does. So if I want to print all that out, which is what I've asked you to do, that's the next step. But for now, I've done everything that I was supposed to do for the first part. Let's put this up on GitHub. So again, I want to do view terminal, and I want to say something like, ready? Git add dot, git commit -m, and I'll say something like it says here in my PowerPoint to do, which is added input and clamping for primary attributes, right? So added input and clamping for primary attributes. Okay, there we go. And I'm going to push it, git push. All right? And that, my friends, is the first half of, that's worth 4 points out of 6 if you just do that. Again, I'm recording this so you have access to it. Okay? So back to this then. I've done this piece, these pieces right here. Your to-do for tonight at midnight, right, is I want you to calculate the secondary attributes: awareness, toughness, and resolve. Awareness is equal to agility plus perception. Toughness is strength and vigor. Resolve is equal to intellect and will. And then I want you to output the format so it looks something like this at the end, all right? And replace the stuff in the angle brackets with actual stuff, okay? That's your job. Make sure you do your commits as it says here, right? And push this out to GitHub. Questions around this? Yes.
Okay, so I'm typing down added.
No. Questions around this. If you have an error, we'll talk about it after. Questions around this. What you're required to do for tonight at midnight. Is it undoable for you?
Is that all? What do you mean? I don't know.
Is it unachievable? Can you not do this? Is this impossible to do for anybody? Yes.
Can we have till Monday again just for this week?
I can't do this week, but I will give you the videos. That's what I will do today. Today I'm going to give you videos, right? So even if, why, you have work or something like that?
Yeah, looking for houses, still like adjusting.
I will negotiate with you for tomorrow. Tomorrow, okay? I'll give it to you guys. I'll move the due date till tomorrow at midnight. Okay? Fair? And I'll publish the video for you guys today. So you have access to it today. So worst case scenario, if you didn't catch anything, you can look at the video. Yes?
Is that deadline moved for everybody or just for them?
Everybody. I don't move deadlines for one person. It's either everybody or nobody. All right? Saturday at midnight. Okay, we'll move it up just for you guys. Just because you asked. Okay? It won't be every time. Okay? But tonight, and the reason why I want to move it and I want to share my video with you is a very important reason. My friends, this is fundamental. If you don't know how to do this, and I'm too fast for you in class, and because we had a power outage, then, I mean, it's unreasonable for me to assume that you can get it done within the time frame. I'm a fast typer. I'm covering a lot of stuff, and this is so important for you to get. If you can't get this, you can't get on with anything else. Yes?
Is there anywhere in this building that teaches you how to type?
No.
Okay.
Typing courses have been deprecated, okay?
So is there anything you recommend to watch or anything like that?
There's typing, just look for Typing Tutor online. Free Typing Tutor online. There's tons. Yes, anything else?
Are you saying that we're gonna have all the stuff that you posted?
Yes. All the stuff I did. I'm not.
Put on your visual.
Yes. So this part here on my Visual Studio, I'm going to push this. I've already pushed this right now. And if you actually look up online on my GitHub, this is the stuff that we do together. I'm sharing this part with you. Then there's one part. There's one part that you need to do by yourself. So I've already done this for you. All this stuff is done. You need to do the next part by yourself, which is format the output. All right? Calculate the secondary abilities. That's what I want you guys to do. All right? Do that little part and make your video. Talk about the stuff that you've learned about variables today. All right? In your video, don't just make, hey, Tom, it works. Okay? Talk about the stuff we just talked about. You have 3 minutes to talk to me. Talk to me in your video. Yes?
Are we expected to be able to memorize this without ever watching your stuff and be able to do it on our own? Like how,
Yes.
How quickly, like, do you expect us to
I don't expect it to be memorized right now, but during your midterm tests, you'll only have access to my code, your code, right? And that's it. And whatever I've given you to do, right? So your midterm tests, I will ask you guys not to use anything, no internet, nothing, just whatever I've given you and your Visual Studio, and that's it, right? No notes on paper. It's going to be, and well, you have access to your GitHub. You will have access to GitHub. Okay, so if you can't figure it out with your GitHub, I don't know, right? Any other questions about in-class exercise 2? Not a problem with what we've done so far. Okay, guys, thank you so much. Good luck. This is due. I'm going to move the due date till tomorrow at midnight. Give me a chance to do it. Okay. Otherwise, that's it for me, guys. Thank you so much, and see you next week.